Yeah, we have. I want to relate it more to geometry, and the second half of this note is you're going to find out a new way to use Pythagorean theorem other than to find a side length. What else can we use in geometry where Pythagorean theorem can help us out? That's our second half. But the first half of today is let's apply it to more geometry. So Pythagorean theorem, if you haven't written it in already, a squared plus b squared equals c squared. And I've never mentioned this. I've always basically just gone off the assumption you understand this is I can't use this on every triangle. Only for what type? Right triangles. All right, so this is only used for right triangles. All right, what's the C for? Let's use our vocabulary here. The C is for what side? Hypotenuse. Don't say longest side. Hypotenuse. And the A and the B are referred to what in the right triangle? Those are the two legs. Yes, those are the two legs that form the right angle. Okay? I wish I could use Pythag in every triangle, but I can't. It's got to be a right triangle. So let's throw it to some geometry now. A parallelogram. Find the perimeter of that parallelogram in simplest radical form, of course. So can you guys go back to your quadrilateral unit for me and bust out a property that'll help me here? I see that this side right here is 11. Any other sides you may be able to find? If you know that side's 11. Here we go. Let's go right to the numbers. Hopefully everyone remembers theirs. 3. Eva? In a parallelogram, opposite sides are congruent. So this side is 11 feet. How can I find the other two opposite congruent sides? We're going to have to use Pythagorean theorem. Everyone sees Pythagorean theorem. I drew this altitude down. That's 6 feet. This part of the base is 2. So let's go Pythagorean theorem. A squared plus b squared equals c squared. Can I have somebody's help filling it in for me? Fill it in for me here. Can I hear from 9? 9, want to help me fill it in? Good job. 6 squared plus 2 squared equals c squared. I'm looking for the hypotenuse. Everyone's all right? Let's keep trucking. I got 36 and 4. So it looks like I'm going to be taking the square root of 40. Simplest radical form, of course. So I'll give you guys a minute to figure that out before we go perimeter. So what is that hypotenuse? What is that side of the parallelogram in simplest radical form? Simplest radical form. What do you got for me? 18. Simplest radical form?
2 radical 10.
Good job. 2 radical 10. Perfect. No issues? Now find the perimeter. Here we go. And this is why I gave this problem in particular. I want to make sure we're good on the algebra part of this perimeter. So the perimeter, all sides added up. I got 11 and 11. And we just figured out the other two sides were 2 radical 10. What can you combine? What can you not combine? Because you cannot combine all 4. Cannot. You can combine the 2 11s. And if what's underneath the radical is the same, you can combine the radicals. But only if they're the same. So does everyone see I got a 10 and a 10 underneath? You can combine them. I got 2 of them here, 2 of them here for a total of 4 radical 10. Can I combine the 4 radical 10 and the 22? No, you cannot. The 22 does not have a radical 10 with it. We are done. That's my perimeter in simplest radical form. You cannot combine because the 22 doesn't have a radical 10 with it. That's as far as you're going. Questions from you guys? Comments? All good on the perimeter? When I can do add radicals and when I cannot. Oh, look who's back. Back again. Our boy, Big Al, coming through. Anybody ever notice he makes quite a a lot of appearances on our tests and quizzes. He's a legend in honors geometry if I haven't talked about him before. He's kind of like a myth, a mystery throughout the year, and then at the very end of the year, I reveal his identity. All right, I'll reveal. It's a big thing. Ask anybody who's done honors geometry before, and ask them about Big Al. They'll know exactly what you're talking about. Legend, Big Al. It does everything. All right. Well, he doesn't want to walk through a pond. Who does, right? So to avoid this pond, he's going to go 34 meters south, 41 meters to the east. So I want to know, how many meters would he have saved if he could actually walk through the pond? Save if he could walk through the pond. All right, so where'd he go? 34 meters. Do I need to put the old compass up here, or is everybody good? We're all good there? Did I need to put that, Jonah, do you think?
Yeah.
Okay, all right, sure. So he's going 34 meters south, right? 34 meters south. Then he's going 41 meters east. So that's where he started. That's where he finished. And here's your lake, right? Here's your lake. Woo, good there. Great picture, right? There's your lake or pond. So if he could walk through the water, I'm sure if he's Big Al, he could walk on water. How many meters would he have saved? Well, by avoiding the pond, how many meters did he go? Let me just make a note here. By avoiding the pond, how many meters did he go? To get from start to finish, how many total meters did he go by avoiding the pond? 75 meters. Yep. All right. Well, if I want to know how much he saved, I got to know how much it is to actually walk through the pond. All right. So how much is it to actually walk through the pond? Set it up for me. 5. Want to set up Pythag there, Greg, for me?
34 squared.
Yep.
Plus 41 squared equals c squared.
Yep. Good job. And I'm going to get fired up here in a second. Just a heads up. Making sure we don't do, yes?
Can I calculate it?
What's the deal with yours?
It's dead.
AKA needs new batteries?
Yeah. So.
All right, real quick, as you're doing these calculations, we get what? 2,837 over on this side equals c squared, right? Everyone's with me? Then you take the square root. Okay, here's where I'm going to get fired up. And it's not your fault if you did it on your own. I just haven't talked about it this year. Hey, when I find C, is that my final answer? Is that my final answer? No. Why am I asking you? Because you should not be rounding that number right now on your own. The only thing we round to the nearest tenth is our final answer. Don't round this number because I'm going to tell you what's going to happen. You're going to round it, and it's going to affect your final answer, and it'll be wrong. Do not round in the middle of the darn problem. Do it at the end. So yes, I'm going to do it too. 53.26349,594. I think. Right? Yep. Don't round in the middle of a problem. It could affect your final answer. So that's how many meters it is if you can walk across the pond. So now let's talk. Saved meters. How do you calculate how many meters you would have saved by walking through the pond? Who's up here? 2. Matt, how much could you save? Tell me how to get there.
You subtract that from 75.
Good. 75 minus, and you can do this. This is fine. I get it. Your little arrow. 75 minus that number. Now you can round to the nearest tenth of a meter. How many meters would Big Al have saved? When you're ready. 13 when you're ready.
21 point. Wait, do we round? After the funnel.
Correct. Yep. So you did 75 minus this decimal, 21 point, round it to the nearest 10. So one number after the decimal now. I got the 21 part. What's the numbers after it?
7.
Yeah. 0.7 meters. Any issues going? We all good? Questions? Again, I know you guys are going to do that. I just wanted to make it a point. We don't round in the middle. We don't round in the middle. We round at the end. All right, you round in the middle, maybe 8. You round in the middle, maybe your answer is 21.6, 21.8, 21.5. All right, that's a problem. Ready to move on? All right, I love this next one. You get to show off more of your algebra skills. It doesn't look like much at all, does it? Number 3. Just a simple right triangle. It's got x on some legs and hypotenuse. Let's use Pythagorean Theorem. I just want to make sure algebraically you're sound. Can you plug in for me first? Let's hear from 4. Griff, can you plug in whenever you're ready? Yep. All squared. Yep. Plus. That's the other leg. Equals hypotenuse. Good job. Great. I know everyone can handle that. That's not why I gave you this problem. Here's why I gave you the problem. X squared. Everybody can do 64. Great job. 8 squared, 64. I'm interested in how you're going to handle this bad boy right here, x minus 4 all squared. Because it's not x squared minus 16. I hate to break it to you. Sorry. Anybody remember this day last year? Or maybe it was a take-home test, like I've heard many of your tests were last year. How do I deal with that? Because it's not x squared minus 16. Hi, Laura.
No. It's x minus 4 times x minus 4.
You multiply it by itself twice. Good job. X minus 4 times itself. So I don't know what you called it last year. Double distribute FOIL. That's what's going on. Go ahead in your group right now. Go. Double distribute FOIL that. Combine your like terms, please, and let me know what you end up with there.
Oh, yes.
Got to write it out twice. Okay, what'd you get? I just want, when I say what'd you get, I want to know after you did x plus 4 times x plus 4, what'd you get? That's what I want to know right now. 19? Plus 8x? Because didn't you get
Sorry, I had,
minus 8x, and then what was the rest of it there, Caitlin?
plus 16.
Plus 16. Good. Everyone good right there? What you get after you're done FOIL double distribute. All right, let's clean this up a little bit, right? I got 16 and 64. X squared minus 8x plus 80 equals x squared. And I'm sure right now some of you are a little confused. Not confused, but maybe a little nervous. What happens next? Because you're probably thinking factoring right now, right? Factoring when you see something like this. And you can't factor unless one side's equal to what? Okay, 0. So how can I move this x squared over? Subtract it over. But what's going to happen when I do? And that's okay. What's going to happen when I subtract it over? It's going to cancel with this x squared on the left. Okay, so negative 8x plus 80. The x squared's canceled. Oh, well. What are you still left with on the right side? 0. Don't overthink this now. Solve for x now. All right, the x squared's canceled. Big deal. It's still equal to 0. Good news, you don't have to factor, but just solve for x now. Move the 80 over, subtract the 80 over to the right side, and then divide by -8. X equals 10. You're good. You're good. It happens. They cancel each other out. Yay, we don't have to factor. Anything from you guys here? That was a big one. All right, now I want to get in the second half, which is what else is Pythag good for other than finding a side length? Believe it or not, you can use Pythag. Oh, we all saw that, huh? Yep. All right, let me put a little pause here on the old video. All right, here we go. So back to my talk. How else can I use Pythagorean theorem? You could tell me just based on its sides if a triangle is acute or obtuse. That doesn't sound right. What do we usually need to tell if a triangle is acute or obtuse? Not the sides, but angles. Not with Pythag. Not with Pythag. Take a look. If you plug your sides in the Pythag, and this is already written here, if the a squared plus b squared side is bigger than the c squared side, that bad boy's an acute triangle. I don't need angles. I already know it's acute. And if the opposite is true, if the hypotenuse squared ends up being bigger, it's an obtuse triangle. So that's how else we're going to use Pythagorean theorem. I don't need angles. All I can need is the three sides, and I can tell you if it's acute or obtuse. I think I'm missing a scenario here. I got greater than, I got less than. What am I missing? Equal to. Breaking news, you've been doing that all your life. If they are equal, what type of triangle am I working with? That's the only time you can use Pythag, right? It's a right triangle if they're equal. So let's test it out. So in part A, I got three sides, 9, 12, and 15. What type of triangle is it using Pythag? What should I be plugging in for A and B then? The two smaller sides, correct. Because if this is a right triangle, 15 would be the hypotenuse. So we're going to say 9 squared plus 12 squared. I'm not going to put any equal sign there because I don't know. How does it compare to 15 squared? That's what I need to figure out right now. How does the a squared plus b squared value compare to the c squared? So everyone's trucking along here. Break your streak. Let's go. So we're all getting 225 on the left side. And on the right side, we also get 225. So if they're equal, 9, 12, 15 would be sides of a right triangle. It would be sides of a right triangle. Okay? Questions? All right, well, this next one's not going to be a right triangle, but what if I have sides 10, 11, 13? 10, 11, 13. 10 squared plus 11 squared, how does it compare to 13 squared? How's this one look? 221 for the a squared b squared side, 169 for the hypotenuse side. So if the a squared plus b squared side is bigger, this would be a acute triangle. Nice, huh? I don't even need to know the angles. Just give me the sides and I'll tell you what type of triangle it is. Questions, comments? All right, moving on. Uh-oh, look what's coming up. I got a graph. I'll let you guys graph it and we'll talk. How can I figure out what type of triangle this one is? So go ahead, graph. So close, everyone, so close. You can taste the homework. All right, let's talk. Because we're actually going to split this up in the class. We're going to split up the duties here. How am I going to know if this is acute, right, or obtuse? Well, there's no way we're going to know the angles right now. Absolutely not. We're not going to find the angles. So we need to rely on the side so I can use Pythag to see what type of triangle it is. But I need the side lengths. How can I find the side lengths? Using
Distance formula.
distance formula, yep. All right, so here we go. I'm going to split it up now. Two groups are going to have one side. I'm going to split this up so you don't have to do 3 distance formulas. Why would I want to do that in an honors class, right? Okay, these two groups right here. Matt, pick a side.
XY.
You guys have XY. Go, get after it. You guys right here. Serena, pick a side other than XY.
XZ.
You guys have XZ. Go after it. Last two groups, you have ZY. Go ahead, get after it. Make sure you check with people in your group. Oh, yeah, that might be the first thing you might want to discuss because I'm not giving it to you. What's the distance formula?
X2
Minus X
X1. And then there's also
One group will get a radical you can break down. Don't bother breaking it down. I'll tell you why at the end. Don't break down your radical. Just keep it underneath, the number underneath.
Oh yeah, that's square. Yeah, that's right. Yeah.
But is it minus or plus that's in the middle?
Oh, boy.
Plus.
It's plus.
It's plus and then they minus each other in sections.
So minus inside of parentheses.
And then check with your group members to make sure everyone got the same
Over, like,
distance.
2 or something? No, that's the midpoint.
No.
I didn't know there was plus.
Yeah, I got 29.
Okay, do a quick check within your group. Make sure everyone's got the right distance from your side, and then we'll write down the other 2 sides you don't have.
I know. Just right
Okay, here we go. Now, what'd you guys have?
We had radical 29.
XY? Okay, XY, everyone. Jot it down if you don't have it, is the square root of 29. Perfect. Next up, who had YZ? YZ? Anybody who had YZ? Square root of 20? Again, I'd like, usually I'd have you break that down, but I'll show you why in a second. I don't want that. I don't need it broken down. And then that third side, XZ? What do you guys group set at xz? Square root of? Square root of 13. Good. Okay, now it's time to test. Now it's time to use Pythagorean Theorem to see if it's acute, obtuse, or right. What are the two smallest sides here? Okay, radical 13 squared plus square root of 20 squared. How does that value compare to the biggest side, the square root of 29, all squared? You guys remember from last year? Anytime you square a radical or multiply it by itself, what happens? Number underneath. All right, so square root of 13 squared is just 13. Check it on your calculator if you're unsure. And again, this is why I didn't need you to break it down, because what's this just going to become? Square root of 20 squared? Just 20. And then square root of 29, 29. So what do we notice? The a squared b squared side is bigger than the hypotenuse side, which would make this, what type of triangle up here on the graph? 19? Acute. Good job, Kitten. Good job. Acute. All good? All right, last one I want you to do in your groups. I'll give you about 5 minutes, a little Regents type question. I got Big Al says the two triangles are congruent. Welcome to his brother. Little Mike says the two triangles are similar. Are Big Al and Little Mike both correct? Or maybe it's one right and not one wrong. You discuss in your group. But what I had given you is not enough to say they're congruent or similar yet. You're going to have to find some more info. Okay, so discuss it in your group, 5 minutes, and get back together as a group. Are they both correct? Only one correct? Well, I'm sure you found the missing side of each triangle and found them to be 13 for the hypotenuse and 12 for the other leg. So let's take Big Al's statement first. Are they congruent? Yeah, darn right they are. All right. Why? Why? Come on, we've gone through congruent triangles all year long here. Tammy? Let me challenge you. What other method could you also use? Side angle side. Let me challenge you even more. Give me a third method you could have even used.
What is like?
HL. Yep. HL. The right triangles. The hypotenuse and the legs are equal. So HL. Good. And little Mike, are they similar? This one probably the tougher one. Are they similar? Yes. Why? What's that? So side similarity. They're all in the same ratio of 1 to 1, right? 5 to 5, 13 to 13, 12 to 12. Any other methods? Where's the third angle? Where's this? I see the right angles. Where's your other pair?
Because they're congruent, so.
Okay, so because they're congruent, then they're similar. Yes. Okay, so you could say because the triangles are congruent, that makes them similar. Yep. So they are similar because I'll write a side similarity. Side angle side similarity would work too. Because they're congruent, therefore they're similar. All good? Before we leave today, just take a peek. They're not going to be written in the book tonight. I have the rounding directions right here for you tonight. Also, before you leave, everyone grab your calculator. Do you know how to put a fraction into your calculator? Because some of the problems tonight are going to look like this. This will be 3/4. This will be 5/8. Find the hypotenuse. Everyone knows alpha y equals? All right. Paul, you can put it in parentheses on yours. Okay. Everyone's good there. I want to make sure. And and are we good here? If one of the sides is 5 3/4, you do alpha y equals, and I believe you can pick number 2 instead and type it there. Okay, so I just want to make sure you're good with your calculator because I know you're going to get fractions tonight. All right, guys, nice job today. You got 5 more minutes. Just relax. Thank you.